Hello, Legacy Sabers, Marsh here. So today we're going to talk about logarithm basics with LN. You're going to want your foldable, perfect roots chart, and then you're also going to need a calculator that you would use on a learning check today. Our essential questions, two of them. What's the opposite of an exponential function? And how do you solve an exponential equation that cannot be made into a same base? Now, what we're focusing on today is what's called a logarithm. And a logarithm is just a special way to ask a very specific question. Now, logarithms are written in a very special way. They look something like this. And to read that in English, we say this. We say log base b of a is x. So log base b of a is x. Now, you might see people right around the A, parentheses. If there's only one thing inside the log, people do not usually put parentheses around it. However, you will find I, Miss Marsh, usually do, just so there's no ambiguity for it. Now, the specific question that we are answering with a log is, what exponent is required to go from a base of b to reach a value of a? So right now, exponential form is what you guys are used to. So like base to an exponent equals a value. For example, possibly like 2 to the third equals 8, right? 2 being the base, 3 being the exponent, 8 being the value. Now, what the logarithmic form does for us is it allows us to isolate the exponent. So it asks us, what's the exponent of certain base to get this number? So if I wanted to convert 2 cubed equals 8 to logarithmic form, I would have the word log. The base would be the same base I have here, which is a 2. So you'd have a little 2 written there. And then the value is what we are equal to in the exponential form. So I'm going to put that in parentheses for that value. 8 equals the exponent. So you're always going to find that your logarithmic form is going to equal the exponent of the exponential form. So a lot of people will say is you will find that you'll almost do an e value to go to log. So you'll start at the base, go to the value, and then swap around to get to the exponent. Some people have said that you do almost a g to go to exponential when you're in the log. So you can go like this, beep, 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 kind of like a sideways G if you kind of look at that. You could also kind of do the E with that one as well. But you have to be very careful how you draw the E. What this allows us to do is we go between the two things. And if you need to get to an exponent of a exponential, you can go to a logarithmic. Now, there are logs of all kinds that we have examples here. So I can have a log of a base of a of x equals b. That just turns into x equals a to the b. If you have a log with no base on it, technically that is called a common log, and there's a little base of 10 on there. So log base 10 of x equals b, we could say x equals 10 to the b. So notice x is, or b, excuse me, the answer to my logarithmic is the exponent right there. And then we have what's known as a natural log. The natural log is a log that has a base of e. So when we visited exponentials, we learned about e, Euler's number, 2.72 roughly, kind of like pi. So if we have a base of e, he has what's known as a natural log, or ln. Now, if you see ln, technically there's a little e on there for a base. We just don't write it. You might find that while Marsh is doing this, I'm going to write that little base so it's easier for us to see that that little base on our log, even though it's natural. So ln of e of x equals b there. Now, let's, using our calculators, calculate some logarithms. Now, depending on what kind of calculator you have, you might have to do two different things. If you are using a graphing calculator. There is a log with a base. Because if you're looking at your calculator right now, you're going to be like, oh, Marsh, guess what? I have a log button. Now, here's the problem with this log button that you have on your calculator. Your log button on the calculator is only for a common log, aka log base 10. So if I have log base 4 of 64, I cannot type that into our calculator. So we need to be able to either A, do it in our head, or B, use our calculator. So if you are using a graphing calculator, what you're going to want to do is you're going to want to click Math, and then you're going to want to scroll down, and what you should find is log base. If you press enter on there, you'll see log with a little box, and then you can type the 4 into the first box and a 64 into the second box. You should get 3. Now that makes sense, right? Because if I converted this to exponential, I would get 4 to the third equals 64. That makes a lot of sense, right? Now, if you are using a scientific calculator or a calculator that does not have log with a base, what you can do is use what's called the change of base formula. So you can go log of big number divided by log of a, because you should have a log key somewhere on your calculator. So if I wanted to do log base 6 of 216, I could go log of 216 over log of 6. Now, don't forget, though, please make sure that you use a parenthesis in between. Close that log on the top. Otherwise, you will get a bad answer. The answer to this one is 3, which makes sense, right? Because 6 to what power gives me 216? And looking at our perfect rich chart, 6 cubed gives us 216. ln of 4. Now, you guys have an ln button. So what you're going to want to push is just ln, and we're going to type 4 in the parentheses. We are going to get a decimal, so we're going to do approximately. That's 1.3863, rounded to 4 decimal places to be exact there. Log base 3 of 1 over 243. I'm going to do this one kind of in my head here. So I'm going to convert to exponential form. So I'm going to say 3 to something equals 1 over 243. Well, 3 to the 5th is 243, right? Looking at my card here. Yep, 3 to the 5th is 243. But I need that 243 in the bottom. So a negative exponent, right? So 3 to the negative 5th. So I bet if I use my calculator here quick and typed that into my calculator, yep, I get an answer of negative 5. Log base 5 of 125. So what is the exponent that on the base of 5 can give us 125? 3, right? 5 to the third is 125. ln of e. So now I'm going to push ln on my calculator and then type e, well, probably to the first, right? Oh, I get an answer of 1, which would make sense, right? Because base on that ln is e, so e to the first would in fact give us e. This ln over here, the ln of 4, what we're finding is e to what power will give us 4. We can't do that in our head. We have to use the calculator to find that one. So like I said, if there is not a log base present, and it is normal log, then that means you're going to have 10. That is referred to as a common log for our base. Now, let's convert between exponential and logarithmic forms so we get kind of comfortable here. So I'm going to start in exponential. Notice there's no log. That's why I know it's an exponential form. So I'm going to have log base of 1/5. So it's going to be a little 1/5 of y equals the exponent. Okay, 1/5 y x. Same thing with our e. So that'll be log with a base of e of x equals y. Now, log with a base of e is just ln, right? So I'm going to rewrite this problem here. I'm going to write ln of x equals y. These are equivalent. We just don't like to write log base e. We like to write ln instead. Okay, that ln still has technically a little base of e, but we like to write ln instead of log base e. 6 to the y equals x. So log with a base of 6 of x equals y. So just converting between these two forms is our main focus today, for the first half of our video at least. So now I'm in log form. I need to go to exponential. So that means the base is still the base. Okay, so u to the v power is 15/16. So this is always going to be your exponent in your exponential form. This is always going to be the base. So this one, 7/4 to the y equals x. Technically, we'd probably put the 7/4 in parentheses. Now notice ln, we're missing the base. So we're going to put a little e there so we can see the base. So that would be e to the 4th equals u. Kind of fun, right? Now, why logarithms, Marsh? Why do I care? Well, keep in mind, there are two different types of exponential equations. One's where you can solve with common bases. That's what we did last time we solved exponential equations. But what do you do if you have exponents on one side and you can't make a common base? Okay, that is the problem that we have here. For example, 100, I can't make 2 to a power to be 100. Exactly. So what I need to be able to do is use a different form of solving. So if I have exponents only on one side and I cannot make a common base, what we're going to do is we're going to isolate the base, use inverse operations to change into a log form. So first thing, got to get 2 to the x alone. So this guy's got to be alone first. So we're going to add the 1. So I'm going to get 2 to the x equals 7. Now, I cannot make 2 to a power be 7, so I need to use inverse operations, aka change to log form. So I'm going to say log with a base of 2 of 7, because I'm isolating the exponent, right? So log base 2 of 7 equals x. So using your calculator, however you need to use it. So remember again, if you're using a graphing calculator, you're going to click math. You're going to scroll down until you see log base. So log base 2. Of 7. And if you are using a scientific calculator, you're going to want to use the change of base formula, which would be log of 7 divided by log of 2. No matter how you do this, you will get x's answer, and I'm going to round to 4 decimal places to be kind of exact. So 2.8074 for an answer there. And what's cool is I could plug it back in. Now, keep in mind, if you do plug it back in, though you're not required to do so, you would not get exactly 6. You might get like 5.9999 just because of rounding. Let's try another one. Now, notice this one has pretty much everything. I need to get this guy alone first. So I'm going to add the 15 over. Get myself some 19. I'm going to take care of that 1/2, so I'm going to multiply by 2 on both sides. Oops, wrote that parenthesis a little too fast. That'd be 38. Now, I cannot make a same base, so I'm going to go to a logarithmic form. So I'm going to say log with a base of 10 of 38 equals 2x plus 3. Ooh, it's a common log, so that means I can just use my log key. So log of 38, using my calculator, I get an answer of 1.5798 equals 2x plus 3. Now, I'm going to just keep that number running on my calculator as I do all of the other operations to get x alone. So I'm going to subtract 3. And I'm going to move over here. Negative 1.4202 equals 2x. I'm going to divide by 2. And we're going to get an answer of x equals negative 0.7101. Exact. Now keep in mind, 4 decimal places kind of gives us pretty much an exact value. But again, if you cut off, like maybe you push the refresh key or clear key, you might not get the same number I get at the way ends just because I kept this rolling number throughout my calculator. So be careful with that. Let's try with a base of e this time. So again, the base guy has to be alone. So this e to the x plus 2 needs to be alone. I'm going to divide by 4. I'm going to get e to the x plus 2 equals 8. Now I got to go to logarithmic form. So I'm going to get log with a base of e of 8 equals x plus 2. Now log of e, that's just ln, right? Just convert that, change that back to its form that's more acceptable. Ln of 8, that is a calculator answer. I'm going to get 2.0794, rounded to 4 decimal places, of course, and subtracting 2, I almost did that on my calculator, 0.0794 approximately for an answer. If you want to write this one into your notebook, you can. If you're like, ooh, Marcia, just kind of want to watch you, or maybe you want to try this one, pause the video, and then try it yourself. But I'm going to do this one for our last one. Not required, of course, to write in your notes. So again, oops, lost my pen. I need to get this part alone, right? So I'm going to subtract 7 and divide by 3. So 33 minus 7 divided by 3. Ooh, that one doesn't turn out nice at all, does it? So 5x minus 5. That's just 26 thirds. I'm going to leave that as a fraction there so I don't have to mess with decimal junk. So now I get to convert to a log. So log with a base of 2 of 26 over 3 equals 5x minus 5. So using my handy dandy calculator, again, either change a base or by using the math button, whichever one you need to use, I'm going to find the answer to the log spot there. I get an answer of 3.1155. So to that, I'm going to add 5 and divide by 5. So my official answer, after I do all my work, we would get 1.6231 right there. And that is the end of this video. I hope you enjoyed working with logarithms and how you're starting to use your calculator some more. We'll keep practicing with logs because they're going to keep showing up. And I look forward to keep practicing with you. I'll see you later, Sabers.